Page 264, this is going over the Pythagorean theorem. That's supposed to be a y. And what you see here is this figure for this is looking at number 21. It says that MN is 6. Okay, so this is the actual length of that. And then it says tangent of MLN, so of this one right here, okay? So we know from SOHCAHTOA, tangent means opposite, so tangent means opposite over adjacent, right? So that's going to mean from this angle, opposite over adjacent is going to be 12 to 5, okay? So I'm going to put that here like this. Because what that means is it doesn't mean that this side is measured at 12, it's the representation, okay? And what you see here is that 6 is the actual measurement of this side, and 6 is half of 12, right? And what you see here is you don't have to use a Pythagorean theorem because you got something that you need to remember. The special right triangles are 3, 4, 5, 6, 8, 10, 5, 12, 13. Okay, so this one is clearly 5, 12, 13. Okay, they want to know in the end, what is LN? What is this? The answer is not 13. Okay, but you see that if you look at answer C, there's a trick answer there, which is 13. This is just a representation of the sides, but this is the real one, okay? 6 is the real measurement of MN, and that is half of 12. Therefore, what is this? It's going to be whatever is half of 13, and that is going to be 6.5, and A is your answer. The next page is page 265. And this right here has a triangle that looks like this. Okay, and it says Tom sketches out the diagram above for the sail of a boat he is building. What is the sign A? They want to know what is sign A here. So if A is there and A is here, and they tell us that this is 12 and that this is 18 feet, we already know here that this side and this side are going to be the same because this is an isosceles triangle, obviously. If these two angles are the same, then those two angles are the same, or those two lines are the same. And also, we know that because the angles at the base are equal, this height will also bisect the base. So we know that technically this is 9 and this is 9. Okay, so they want to know what is the value of sine A. Sine, so, is opposite over hypotenuse. Okay, so we already know from this, what is the opposite? The opposite is 12. We know that. But we need to find out what the hypotenuse is. We got 9 and then we got 12. Okay, and so I'm just going to try to reduce this down. 9, if we reduce this down to divide out 3, look at my right triangles. I got 3, 4, 5, 6, 8, 10, 5, 12, 13. This is going to be 3, 4. Obviously, this one is going to be a 5 then. Okay, and so on this side, I multiplied this by 3. And so I'm going to see how it originally was a 9, but I reduced it down to a 3. I reduced this down to a 5, but I'm going to have to multiply it by 3 to get the original side, because all of these I divided by 3 to get there. So this side's actually 15. Okay, so it's going to be 12 over 15. But I could reduce that down further. I could take a 3 out of each one. That's going to be 4. Take a 3 out of there. It's going to be 4 out of 5. Which really is the original sides right over there. So that's how you get that answer. For this next question, this is using the special triangles. This is a special right triangle. There are two different types that you guys know about, and we went over them right over here. You're going to get one that is the special right triangle that's 30, 60, 90, and then you got the 45, 45, 90 right there. Okay, so in this picture, it's going to give you X and it's going to give you Y. So we know that this is not the 45, 45, 90. It's not that one. It's going to be the 30, 60, 90. Okay, and just because it says so right over here, across from the 30 is the X. I'm going to put that down here. Across from the 60 is the X square root 3. And then across from the 90 is the 2X. For me personally, as a non-math teacher, I always forget this, so I need to write it down just for myself. Okay, it says in the figure above, the measure of angle Y is equal to pi over 6 radians. Which of the following is equal to sine X? Okay, so first, I don't want to work in radians, okay, because you see all the answer choices are not in radians. So what I'm going to do is I'm going to take my radians. It says that it is pi over 6, and if I want to convert it, you multiply it like this. If there's pi on the top, then put the pi on the bottom to 180. If the pi's on the bottom, then put the pi on the top so that they cancel out. Okay, and I'm going to convert this now. 180 divided by 6 is 30. Okay, so really what I'm looking at is that Y is 30 degrees. Okay, so what I did here, step 1, is convert radians to degrees. Okay, and I did that by taking this given right here, and then I'm going to convert it. How do I convert it? Is by either using 180 over pi or pi over 180, trying to cross out the pi's. Okay, so now it's here, so I put that there. All right, then what we need to do here is we know it's a 30, 60, 90 triangle. Okay, so they want to know what is the sine of X. So that's so in SOHCAHTOA. So sine is opposite over hypotenuse. Okay, we know that across from the 30 is the X. We know that across from the 60 is the X square root 3. And we know that across from the 90 is a 2X. Okay, these are the big ones we're looking at here. So if we are looking for sine of X, the opposite is pi square root 3, or sorry, X square root 3 over the hypotenuse, which is 2X. Okay, and when you do this, the X's cancel out, and you're going to be left with square root 3 over 2. Again, this is number 7. In the next question, this one is talking about similar triangles. Okay, so in here you have, by the way, this is page 267, number 8. They give you two triangles right over here. They give you this one, and then they give you a bigger one. Okay, and so it says A, B, C, and then this one is W, X, Y. They tell you that this is angle W, this is angle A, angle B. All right, in the figure above, sine A is 1 over 2. Okay, so SOHCAHTOA, sine equals opposite over hypotenuse, and they say that it's 1 over 2. Okay, so if we do that, the sine of A, then opposite is 1, hypotenuse, which is this, is 2. Okay, so if you were to take a look at this, basically this is like a 30, 60, 90 triangle. 30, 60, 90 triangle. Okay, it was X, X square root 3, and then 2X. Because if your X is 1, across from the 30, if your X is 1, And then across from your 90, it's 2x. 2 times 1 is 2, right? And then across from here, then this right here would be square root 3 because the 1 is invisible. Okay, so that's how we figure out that that is a 30, 60, 90 triangle. It says, what is the value of, and B equals x. X right over here. So this is a similar triangle. It's just smaller. This one is bigger, but the angles are the same. So basically this is a 60 degree and this is a 30 degree angle. They want to know what is the value of sine x. Okay, so what you would do to find out what is sine x is you are going to take sine of x is going to be sine b equals square root of 3. Sine of x is basically going to be the same as sine b, okay, because these are the same things. So sine of x is going to be the same as sine b, again, because they are similar triangles, okay? So if you're to use these numbers here, sine is always opposite over hypotenuse. Opposite over hypotenuse. So of b though, this time, okay, of x, because b and x are the same. So opposite is going to be square root 3 in this case, and the hypotenuse is still going to be 2, because remember that x is 1, so it's going to be 2. And then 3 over 2 is your answer. So just to review again, this angle is the same as this angle. So what you see here, you could use and apply for these because they're the exact same angle with the same distance or the same angle measurements of each side. Okay, the next one is going to be circles, number 10. So if you look here at the question, it says the arc and sector are proportional to the central angle of a circle. Like a part, this little part, over the whole. Okay, it's the same thing as this center angle is going to be over the whole, which is 360. Okay, the arc length, this little thing, we know that the entire arc length in radians is 2 pi r, or I'm sorry, in circumference is 2 pi r. And another way to look at it is this area right here is one part of this entire area. So these are all the variations that you guys may see on the SAT. Okay, so in this circle we have here W, X, Y, and 0. And it says that the figure is not drawn to scale, so do not trust this picture. It says the figure above shows a circle with center O. The center angle described by W, X, Y, central angle. So this is the central angle right over here. Measures pi over 4 radians. Okay, if the circle has a radius of 5, so the radius is going to equal 5. Okay, what is the length of WXY? So what you need to realize about this is that it is basically like a piece of pie crust or pizza crust. And they want to know first, you need to find out first what is the entire pizza crust, and then find out what angle this is and what angle portion that is out of 360, and then divide it out of this. Okay, and so let's do that right now. Okay, first, if you were to take the degrees, okay, pi over 4, this is in radians. If I want to convert that into degrees, I put 180 over here and pi down over here. Okay, so 180 divided by 4 is going to be 45. Okay, so it's going to be 45 degrees. Okay, so 45 degrees goes into 360. divided by 360. 45. So you're going to see that this right over here is going to be 45 degrees. Okay, so 180 divided by 4. 180 divided by 4. 180 divided by 4 is 45. Okay. And then what you see here is that there's going to be now a radius, okay? To find the total crust around here, that's a circumference. Circumference is 2 pi r. So we're going to find that this is 10, because we're going to substitute the 5 in here. It's going to be 10. 5 times 2 times pi is 10 pi, okay? So if I know that 45 goes into 360 8 times, okay? So this piece right here means that there are, and how I find that it's 8 is I'm just putting it into my calculator here. If you take 360 and divide it by 45, you will get 8. That basically says that it looks like this. There's going to be 4 pieces on that side, 4 pieces of pizza on this side, and all of them are going to have a 45-degree angle, right? Because there's 8 pieces. That means that there are 8 pieces of crust as well then. All these crusts are equal. So if they want to know what is this piece, it's going to be 1/8 of the total. Okay, and this is the total. So what I do is divide that number by 8, because I just want to know what is this piece of crust, which is 1 out of the 1, 2, 3, 4, 5, 6, 7, 8 pieces. So I'm going to take the total, which is 10 pi, and divide it by 8. And if I were to reduce that, I'm going to get 5, take a 2 out of there, which is going to be a 4, 5 over 4 pi, which is answer C. And the last question for this lecture is coming from page 269. Okay, this is called overlapping shapes. What they do is they give you a semicircle, and they give you point A, 0, and C. And what I want you guys to notice is that it says nothing about this figure is not drawn to scale. So because this looks like it's in the middle, it does mean that it's in the middle, okay? Then there's something here, B. Okay? So it says in the figure above, OBC is inscribed in a semicircle with center O. If the length of the minor arc BC right over here is 2 pi. Okay, that right there is 2 pi. The area of the semicircle, so the area of this whole thing, area, by the way, is pi r squared. They're saying that it is 8 pi. Okay? 18 pi. What is the length of BC of the triangle? This portion right over here of the triangle. Okay, so that's what we need to try to find in the end. Okay, first we know that they said that O is considered the center of the circle. That means that this line is the radius, this line is also the radius. That means those are the same. That means that this angle and this angle have to be the same as well. Okay, and from what it looks like, everything looks pretty equilateral, right? Because it doesn't say anything about the figure not drawn to scale. And so we could also bet then that this is an equilateral triangle. 60, 60, and 60. Okay? So we want to know what is this piece right over here. And if we want to find out what is BC, we could find out what is any of the others. Basically, BC is going to be the same as the radius. Do you guys see that? And how do we find the radius? Well, they give us what is the area. Okay? So if they are to give us the area of this circle, hold on, let me make sure that it's of the circle. The area of the semicircle is 18 pi. Okay, so what I need to do is actually divide this, because this is of a full circle. Okay, is I need to divide it by 2. Divided by 2. Do you guys get that? Because this right here is of a semicircle. When I use this area, that's of a full circle. So if I want to find the area of a semicircle, I need to divide it by 2. That's why I'm dividing that by 2. And I'm going to find that the area is going to equal, hold on. I'm going to do this, okay? And I'm going to take this regular one, r squared divided by 2 to make it of a semicircle, which equals 18 pi. The pi's are going to cross out on each side, and then what I could do is cross multiply. It's going to be r squared times nothing, so it's going to be r squared equals, that's going to be 36. So my r is going to come out to 6. So I know that if this is going to be 6, then this line also is going to be 6 because it isn't equal to that, okay? So I want to clarify this again. The area of a circle is pi r squared. We know that the area of the semicircle is 18 pi. That means it's a circle divided by 2. So I'm going to do this. I'm sorry if that was confusing. Okay, what we could do is cross the pi's out already and then just cross multiply, and that's how I got the radius equals 6. From there it's really easy to be like, oh, if that's 6, then that right there is 6.